All right, guys. Hey, happy fourth graders. I hope you're having a fabulous day. Today, we're going to continue talking about fossils, right? You've been talking about that a little bit each day. We're going to look at some fossils today and think about different environments they might have been found in. And we're also going to get to practice being a paleontologist, which would be super, super fun. All right, guys. So before we get started, I want to talk about what is a fossil. And we're going to watch this super awesome video where they're going to give us a little bit of explanation to add on to the knowledge that we already have about what a fossil is. Okay. And I have it pulled up right here, so no worries.
Hi, I'm Emerald Robinson, and in this What Is video, we're going to investigate pieces of our past called fossils. Many of us think of fossils as just the remains of dinosaurs. In order to qualify as a fossil, an object must be at least several thousand years old. But the oldest fossils have been determined to be about 3.5 billion years old. Paleontologists, the scientists that study prehistoric life, define a fossil as any type of physical evidence of ancient life. Fossils can be tracks left behind by an animal, impressions of plant leaves in a rock, ancient burrows and dens, or an entire insect perfectly preserved in tree sap that has crystallized into amber. Skeletal fossils are made when an animal dies and are buried very quickly beneath layers of fine rock and dirt called sediment. Decomposers, like bacteria and fungi, break down the animal's skin, muscle, and organ cells, leaving just the bones. Over time, many more layers of sediment accumulate on the skeleton, causing pressure to squeeze out any water left in the bones and to fill in any spaces with minerals. This process, called lithification, results in the stone skeletons we see in museums. Since plants don't have a skeleton, it's much rarer to find a preserved plant. Instead, plants tend to leave a type of fossil called an impression. An impression forms in much the same way as a bone fossil, except that as the plant decomposes, it leaves a leaf print embedded in the rock. We've been able to find fossils that have been buried for millions of years because the Earth's geology is constantly changing. Fossils have given us valuable clues to the Earth's past, and who knows what's still buried for us to find.
For thousands of how-to and advice videos on any topic, visit Monkeys.
All right. So I just thought that was really cool, kind of talking about how a fossil is formed. I know we talked about in our fossil court how the skeleton has to be buried really, really quickly in order for that to happen, usually in some soft mud. So it gets buried quickly, and then pressure over thousands, millions of years turns some of that fossil into that rock using sediment and minerals. All right, let's see. Okay, so who are the people who get to work with fossils? Well, those people are called paleontologists, and they're scientists who get to study fossils. Shout out to Branston, who's in my class, who wants to be a paleontologist one day. All right, so they are these scientists who have such a cool job, get to study those fossils. All right, today we're going to practice being a paleontologist, and we're going to look at a couple different fossils and think about, if I was a paleontologist and I found this fossil, what could I learn from it? All right, so here we are, we're out, being paleontologists, looking for some clues, and we come across this imprint fossil of this leaf. That one's pretty obvious. It looks like a leaf, looks like a leaf we know as today. So here's some questions that we can consider when looking at this fossil. All right. So remember, if we find a fossil, the fossil's thousands or millions of years old. So you're going to compare the modern day animal, in this case it is just a living thing, a leaf, to this fossil. Well, I'm going to think about, this looks like a leaf that I might find maybe in my backyard. It has a lot of different parts to it. And I'm thinking, even though this tree was probably thousands or millions of years old, it still probably came from a tree, still a leaf. This one looks very similar to what we know today. So we know this is probably some prehistoric tree that this leaf has came from. What can we learn from looking at the fossil? Well, whatever prehistoric tree this is, we can figure out that its leaves have 1, 2, 3, 4, 5, 6, maybe some of them have like 7 big leaves on top of it to make this one very large leaf. We could learn about the environment that maybe it grew in. So in number 3, it says, infer what type of environment this animal lived in when it was alive. Well, in this case, it's not an animal, but I would assume maybe this environment, it could have been like a forest. It could have been somewhere in the woods. I'm trying to think of a place where there are lots and lots of trees, maybe someplace that was near like a lake, because I know when a leaf gets buried quickly, it could turn into a fossil. So I'm thinking, this prehistoric tree probably was in the woods. And maybe I found it in a plain. Like, what if I found this fossil in like the plains? I'm like, there's a lot of grass around. I don't see many trees. So you can think about how the landscape has changed over time too. If I found this fossil, this one that clearly used to be in a forest or some woods, in an area where there's no trees, I can infer, well, this environment probably millions of years ago used to be a forest, even though now it's like lots of plains and grassland, used to maybe be a forest. So paleontologists are always coming up with theories about what Earth looked like millions of years ago, what animals looked like millions of years ago, because paleontologists weren't there. They have to study these remains, these fossils, to figure that out. All right, let's look at another one. Here's another prehistoric creature. Maybe you're getting some thoughts of what this might be. This creature lived thousands or millions of years ago, but it probably, you can see some things that are similar to some creatures we have today. All right, so questions to consider here. Okay, does this fossil look like a modern day animal? While I'm looking, I'm seeing, okay, it looks like almost it has little claws. Looks like it has maybe a little tail here, some vertebrae, maybe like a hard shell on the outside. And it has these little whisker things. So I look at this, and it doesn't look identical to a lobster or crab of today, but it definitely looks like one, right? Like I can see, that looks like a crab, or that looks like a lobster. So I'm going to think, okay, this creature, that lived thousands or millions of years ago is probably an ancient relative or of a lobster or a crab. So maybe a prehistoric crab, prehistoric lobster is what I'm going to say that this probably is. I can learn that this creature probably had little claws that could help it, grab things, maybe grab food. I can see that it probably has an outer shell to protect itself, just like crabs or lobsters we know of today. So I can look at this fossil and be able to figure out some attributes that it had, even though it lived millions of years ago. And I can infer what type of environment this animal lived in when it was alive. Well, I know that lobsters and crabs live in the ocean now. So this creature probably too lived in the ocean, or lived in a sea when it was alive thousands of millions of years ago. So I can compare what I know about current creatures to kind of help me figure out about these prehistoric creatures that lived. You may be doing something similar in some fossils that you will look at today or maybe tomorrow. So think about these creatures and what we can learn from them. Okay? Thanks for listening. You guys are awesome. I hope you had fun being paleontologists today, and I will see you guys next time. Bye.